Hello and welcome to today's screencast. My name is Peter Spergata and I'm a solutions architect with the Extensibility Engineering Organization here at Arista Networks. The Extensibility Engineering Organization works closely with customers in developing extensions to our flagship operating system, EOS. Today I want to share with you a couple of extensions that we've developed that are really geared towards helping with managing the maintenance activities on a network infrastructure while live traffic is still flowing through the nodes. The first extension that I want to share with you is one that we call maintenance mode. Maintenance mode is an extension to EOS that allows you to take an EOS-based node and put it into what we call maintenance or offline mode. In this mode, that node will no longer be part of the primary forwarding path for live data traffic on your network infrastructure. However, it's still fully accessible by your operations staff to allow for maintenance activities to occur, for software upgrades to happen, and all of this is done in a very graceful manner. So we very gracefully take that node out of the primary path and then we reinsert it gracefully back into the primary path. The other extension that I want to share with you today is one that's called Snapshot. Snapshot is an extension that will catalog the state of various pieces of the operating system at a given point in time. Things like the number of MAC addresses in the MAC table, the number of routes, the route attributes, the interfaces, VLAN, and so forth. By creating snapshots at various points in time, say before a maintenance window and then subsequently after that maintenance window activity, we can then compare the information to validate that the network has indeed normalized to a state that we expect it to be in. So we can very quickly understand that if a maintenance activity potentially had maybe an unintended consequence of certain MACs not showing up or certain VLANs no longer being available. So I want to demonstrate these two activities or these two extensions for you in today's screencast. The diagram you see before you is actually a diagram of the live network we've got running behind us, and it's really composed of the 4 nodes you see here. Router 01 that you see at the top of the screen is just simply a EOS node that's running BGP and has an eBGP connection to EOS 1 and EOS 2. EOS 1 and EOS 2 are configured in an MLAG configuration with an active-active topology connecting to TOR or top of rack 01 at the bottom. In the current network, top of rack 01 will utilize both EOS 1 and EOS 2 as it communicates with the rest of the network infrastructure. However, what we want to do is we actually want to take EOS 01 out of production so that we can work on it, and then we want to gracefully reinsert it back into the network infrastructure. So I've got a SSH connection to each of my devices, TOR1, Router 1, EOS 02, and EOS 01. EOS 01 is where we'll spend most of the time today. So the first thing I want to do is I'm going to simply do a show interface status and just kind of get a feel for what the interfaces look like at the moment. So we can see from the output of this command that Ethernet 1, 2, 3, and 4 are all up, and that we've got 2 port channels configured, port channel 1 and port channel 10, each in trunking mode. I can also take a look at my MLAG configuration. I can see that I am connected to an MLAG peer, and that MLAG configuration is up and active right now with one fully active MLAG port. Now the first thing I'm going to do before I actually put this node into maintenance mode is first thing I want to do is take a snapshot. So you'll notice when we develop these extensions that they're integrated right into the fabric of the EOS CLI. So I don't need to learn anything new. I do not need to train my operations staff on how to do anything at bash shells or learn the underpinnings of Linux. I simply can use EOS commands that I'm used to using on a daily basis. So the first one we're going to do is I'm going to take a look at snapshots. And so as you can see, just simply providing a question mark, I get context-sensitive help with this extension. And when I do a show snapshots, you'll see that I don't currently have any snapshots created. So let's go ahead and create one. And to create one, we just simply do a show snapshot, create, and we'll call this one snapshot 1, and this is taken before maintenance activity. And we'll do a show snapshots one more time just to make sure. Yep, and sure enough, there it is. Okay, so we've got a snapshot now of the current state of our system with all of our interfaces up and running and so forth. The next thing we want to do is we actually want to now gracefully remove EOS01 from the primary path of the data traffic. So we're going to use maintenance, or we're going to utilize the maintenance node extension to do that. So if I just do node question mark, we can see that I've got two options, which are the activity list and the state. But before we use those, the first thing I'm going to do is I want to do a show node state, and I can see that the node is currently in online mode. I can also do a show node activity and look at the list of tasks that it's going to perform in order to take the node offline. So the first task it's going to perform is it's going to do BGP route map. Now these are all configurable tasks that are configured by a set of configuration files, and the first task is again BGP route map, and this will poison all the BGP routes. The next task will be to shut down upstream interfaces. The third task will be to shut down downstream interfaces, and the final task will be to shut down the MLAG operations. If I look at the activity list for bringing a node online, we're going to see it's the same operations, we're just doing them in a different order because a different order makes sense for bring up. In this case, we'll start with bringing MLAG online, turn on the upstream interfaces, we'll normalize the BGP metrics, and then we will turn on the downstream interfaces. On each of the other consoles, you'll notice that I've got console logging turned on, so we'll actually see that this is happening in real time as we progress through. So the first thing we want to do is we want to go into node state, and we have two states, offline and online. Well, since we're already online, let's go ahead and do offline. So the first thing it says is it reminds us that this command is going to put this node into offline mode, which means it'll no longer be in the forwarding path for data traffic on the network. And then it reminds us what the current activity list is, and it gives us the opportunity to either break out of it or go ahead and continue. So in this case, I'll say yes, I want to continue, and it'll start its process. So you can see as it runs through, we can actually see activity happening on the network as it shuts down the various protocols running on the network. Now, as this activity is running, what's happening in the background with this particular extension is it's actually monitoring the state of the changes that it's making. So in the first activity with BGP route map, it's going to poison all the BGP routes so that this box is no longer considered the best path to get to the top of rack switch 1. It will wait until those metrics have propagated through the network before it moves on to the next task. And this will be true for each task. Upstream interfaces will monitor the operational state of the interface to make sure they're operationally down before it moves on to downstream interfaces, and so on we go. Now at this point, I can simply do a, for instance, show interface status, and I can see that all of the interfaces are now in a disabled state. So this node is actually technically out of the forwarding path for the network infrastructure. I can now perform any maintenance activity that I wish on this node without having to worry about affecting live traffic on the network. Now, just for demonstration's sake, I'm going to go ahead and I'm going to do a snapshot at this point. So I want to do a snapshot, create, maintenance. This is in the maintenance window. And I'll do a quick show snapshots to make sure that I did capture it, which I did. And I can also do a show node state to confirm, yep, the node is indeed in maintenance mode. So I'll go through and I'll perform all of my maintenance activities at this point. And once I'm completed with my maintenance activities, it's time to bring the node back up and reinsert it into the operational network. And the way we're going to do that is we're going to just simply do a node state online. So when I type node state online, it again reminds me that we're trying to place the node into an online state, and it will again start to fully participate in the forwarding path for all routes in the routing table. It gives me the opportunity to either cancel out or go ahead and continue. And I'll say yes to continue. And you'll notice it'll start to work through the activity list again, starting with turning on MLAG operations and then enabling ports and normalizing all of our routing metrics. You also notice here that all the different nodes are actually changing in real time as these activities are happening. As each activity runs, it continuously is monitoring all of the appropriate states for the things that it's changing, and it will not actually move on to the next activity until the state has reached the desired setting. Only then will it then move on. So in this case, we've gracefully inserted the node back into the network infrastructure, and if I do a show node state, I can see that the node is indeed now online. I can also do a show interface status very quickly, and I can see all my interfaces have reconnected to the network. Now that my maintenance activity is complete and I've gracefully inserted my node back into the network infrastructure, I should be back into a normalized state before I started any work on the network. The way I can verify that is to do another snapshot. So I can do a snapshot, create, normal. This is normal operating mode. So now when I do a show snapshots, again, I've got snapshot 1, which is where we started. I've got a snapshot of what it looked like in maintenance mode or in offline mode. And then I've got a snapshot normal once we've returned out of maintenance mode. So what we can do is we can actually then compare the attributes in these various snapshots to make sure the network has normalized the way we expect it to. And the way I do that is simply by doing a snapshot compare and then provide its names. Snapshot 1 and maintenance. And you'll notice that it goes out and it looks at the summary information. It gives me a comparison of what's changed. So in this particular case, I can see that from a baseline summary, I had 13 total interfaces, but in the maintenance snapshot, I only had 10 interfaces. Even more detail tells me that I had 7 total interfaces. All 7 were up in the snapshot 1, but that in the baseline or in the maintenance window snapshot, I had 5 total interfaces, 1 up, 4 down. And of course, the 2 missing ones I can see further down are my 2 VLAN interfaces that are no longer in up or down state. They're actually no longer in the network. I can also very quickly tell by the changed column what has changed and what has not. So I can see that I had 2 lag interfaces when I started and I had 2 in the current snapshot. That value hasn't changed. So using a screen and a utility like this, when I'm doing maintenance activities, especially when I'm doing maintenance activities that are perhaps emergency maintenance activities in the middle of the night and you have tired operations staff, it's very easy and very quickly are you able to determine, are you back at a state that you expect to be or are you not, and what's changed. It's a little bit more efficient than the very traditional stare and compare of 2 show commands. We can actually take this even a level deeper. So let's say I want to know not only the fact that I had, say, a number of routes change in this case, but what has changed in them. So in this case, I'm going to add the IPv4 routes keyword. And when I do an enter there, you're going to see that I'm looking at the IPv4 table, and I can see that I used to have 30 routes. Now I only have 8. And that I can actually see what's changing. And so if I look here, I can see that, for instance, prefix 172.16.10/32 is no longer in the current snapshot, which tells me that 172.16.10.0 used to be in the routing table, but no longer is. So let's look at the same information, but in this case, I'm going to compare my pre-maintenance window snapshot with my post-maintenance window snapshot to see if I got back into the state I expected to be in. So we do a show snapshot. Snapshot 1 is the pre, normal was the post. Compare, I need the compare keyword. snapshot 1, and then normal. Snapshots, compare, no show command. This is a executable command. And in this case, when I actually hit enter, you'll notice that I'm comparing snapshot 1 now with normal. And in this case, I can see that prior to my maintenance window, I had 13 interfaces. After my maintenance window, I had 13 interfaces. But I did have one value change, and it sees that I had one LLDP neighbor change, and that's just simply because the LLDP neighbors were not the same number before and after, but that's okay in this particular case because it just hadn't discovered it. Working down through the list, I can see that I've got 7 interfaces, 7 were up, 7 are still up, and so on through the list of attributes. I can also look at the IPv4 route table just as I could before, and I can see that I had 30 and I still have 30. But what has changed is you notice that my adjacency index has changed, but that's not a big deal. It doesn't really affect forwarding, so I'm okay with that. By utilizing these two extensions, snapshot and maintenance mode, we now gain a bit more control around how we can operate an Arista EOS-based solution. We can utilize these two extensions together or independently to bring real innovation around how we actually execute our maintenance windows. And we can do this in a way that's integrated tightly within the EOS system. So we don't have to train operational staff on new tools and new utilities to use. They simply use CLI commands that they are comfortable using and that they've been using in the past. I hope you find this screen capture informative and look forward to working with the Arista Extensibility Engineering team in the future. Thank you.